Good day, mathletes. In this video, we're going to explore a visualization of the discriminant and how it tells us how many x-intercepts there are for a given parabola or a quadratic function. So let's look at a pretty basic example of a quadratic, like 2x squared plus 4x, and we could say a number like plus 5, and fairly quickly we could see there really isn't an x-intercept for a quadratic function like this. And we could try to change things around and see how things are impacted. I could change this from a positive 5 to a negative 5 and see very quickly that there are different a, b, and c values that would impact the position of this parabola and therefore how many x-intercepts there actually are. For the moment, I'm going to change this to a plus c and keep this a little bit more dynamic for the moment so I can play with this and move it up or down, the c value, moving it up or down, and kind of determine a different number of x-intercepts based on the value of one parameter in this function. And so the more important thing for this conversation, though, is to examine the discriminant and how the discriminant determines how many x-intercepts there are for a function like this. The discriminant value is b squared minus 4ac. And we'll relate this back to the quadratic formula in just a moment. But our b value in this case is a negative 4, which we are going to square. B squared minus 4a, in this case is a 2, and our c value is c. Now I can see the value that is being computed right now is a negative 32. So our discriminant is negative 32. How many x-intercepts are there? None. There are 0 x-intercepts. Our discriminant is what we're focusing on, negative 32. As I shift this parabola up higher, I'm seeing that discriminant continue to be negative and even more negative. As I shift this parabola down with a changing c value, I'm actually seeing that discriminant value eventually become quite positive. And as I visually inspect, there are 2 x-intercepts, I can see that positive value of the discriminant. All of the discriminant values are positive. All of them now with no x-intercepts are negative. And there is a perfect location here where our discriminant is 0, where we in fact have one perfect x-intercept. So we either have a set of no x-intercepts, a negative discriminant, positive discriminant, 2 x-intercepts, or as we saw a moment ago, the perfect scenario where there is in fact one x-intercept. And that is when the discriminant is 0. Now, why does that actually occur? Let's have a quick look at the quadratic formula and just inspect a very specific part of it. Our quadratic formula is negative b plus or minus that giant square root of b squared minus 4ac all divided by that 2a. So with our quadratic formula, there's a very specific part of this under that square root that is that b squared minus 4ac. That's our discriminant right in here. So this discriminant is special because a square root is special. You cannot square root a negative value, and that's important. Negatives become a problem under a square root, but we also have this plus or minus, which is on its own uniquely important as well. So let's inspect what happens if our discriminant value had a specific sign. So regardless of what's happening in the nuances of those calculations, what if I were to say we've got a negative value for the discriminant, a negative number. And I really don't care what the number is, only that it's negative. If the combination of those parameters turns out to be negative, and I try to compute the square root of a negative number, we get no solution. And we saw this a moment ago when we saw a negative discriminant value that there were no x-intercepts. So very clearly, a negative under a square root, a negative discriminant is not able to compute anything and there is no solution. There is no x-intercept that results. If we have a 0, that perfect scenario, we saw visually that there was one x-intercept. Now, why does that happen? Well, it is because this plus minus is very much impacted. Plus or minus the square root of 0. Now, we can do the square root of 0 is in fact a 0, but the square root of 0, adding 0, subtracting 0, doesn't really do much for us. So in the end, we have one value that is determined. There is one x-intercept that is determined. And so that is unique if the discriminant is in fact 0. The last scenario is if we do have a value, and we'll just say there is a number under here, and whatever that number is, there should be A on the bottom, whatever that number is that is kind of a calculation, we have the plus that impacts it and a minus that is impacting it, and two calculations resulting in two different x-intercepts, or the same. But we have three separate scenarios based on whether there's a negative discriminant, a zero value, or a positive number, which results in those two calculations. So visually, we saw the impact of the discriminant, and numerically with the quadratic formula, we're seeing the impact of that discriminant on the plus minus and on the square root.